Hello, Lamai. I hope you can see me and hear me. Hello, students. I think that you can see me and hear me. Okay. Okay. Right. Today we are going to learn something called the extension of uh, screw principle. So far we have learned what is the screw principle and application of the screw principle, that of micrometer screw gauge. Right. Micrometer screw gauge. So let me give you another kind of like very basic introduction about screw principle again, because the spherometer is a kind of little bit difficult lesson, little bit. But if you have a really good understanding about screw principle, it's going to be very easy, that absolutely easy. Now just have a good look at in terms of screw principle, right? So the screw principle, I told you that there is a screw ball. In the screw ball, there are certain specific lines that we used to call as threads. Between length between these two consecutive thread is known as pitch. We used to know it as pitch. So you are going to actually divide a pitch into certain number of divisions in a main scale. So normally it can be a 50 or 100. That's what normally. The division can be 50 divisions, 50 equal divisions, or 100 equal divisions, right? Okay. Now I told you how to find out the least count of this screw gauge, any screw instrument. Okay. So in that case, you are going to divide each by number of divisions of circular scale. Number of divisions of circular scale. Most of the time, this type of pitch may come up with 0.5 millimeter main scale or 1 millimeter main scale. You may remember this thing. We learned this in the last week. So for 0.5 millimeter and 50 division and 1 millimeter and 100 division normally come up as a pair. So for the instrument coming up with 0.5 division to 50 division in the main circular scale, the least count is going to be 0.5 millimeter over 50. So the answer will be 0.01 millimeter. This is a rapid revision of what we learned in the last week. And again, the other type is 1 millimeter pitch scale, and you divide that into 100 equal parts. So the least count again be 1 millimeter divided by 100. So your answer will be 0.01 millimeter again. I'm sure you understood this. Ne? Hello? Hello, students. You understood this or not? Okay. We did many of the calculations using this. So today, from this method, we are going to learn something called spherometer. Spherometer. So before learning spherometer, I will just tell you why we have to learn something called spherometer. Okay. Let me turn off the other light. Okay. Spherometer. This light to the other one. Okay. Let me check. Okay, students. So sometimes we have to measure diameter of a small sphere to find out the radius. So you can just find out. Let me show you with the demonstration. Let me show you with the demonstration. Give me a 1 minute. So this is called Newton's cradle. In this Newton's cradle, there are metal spheres. See, these metal spheres are very small in size. If I want to find out the diameter of this one, I can use this type of micrometer screw gauge and hold it in between these opposite sides. And now see, you can just measure. It is somewhere about 11.43 millimeters. What is it? 11.43 millimeters. Length is like, sorry, diameter is like 11.4. I can just get like 4 millimeter. So I need the radius. I need the radius. What can I do to get the radius? I just simply can divide it by 2 because diameter is twice the radius. So the radius is diameter over 2. So I can just simply get the answer. It is like 11. Nearly like 5.72 millimeter. So you can find it. But the problem is if the spherical object is a very massive one, very big spherical object. So you want to measure a very huge spherical object and find out the diameter. Still you can use a technique like this and measure. But there is a problem. But if you find only a part of the spherical surface, you might not directly understand what I'm talking about. It is like, imagine you have a big apple. It is nearly spherical. You are only taking a slice like this. Slice. So apple is nearly like spherical. If it is assumed to be like sphere, so you have only this part. how can you measure the radius? Huh? Right. Let me give you one more user-friendly example. If you find a dialog TV antenna, dialog TV or any dish TV antenna. So this antenna, you only have what? A small slice of a sphere. If you complete it, it will look like a sphere of like this. So if you only have a slice, good example is a spherical mirror, like a concave mirror, convex mirror. If you have a concave mirror, you want to find out the radius of inner surface. So the concave mirror is also something like this. If you complete, you can find out the what the sphere. So this one is only a slice. So how can you find out the radius? You are helpless. But to find that radius, we have a method. That method is called Spherometer. So we have a device and some mathematical method all together coming up to give us the detail about the radius. That method is called handling a spherometer. So the device is spherometer. Can you understand why it is important to learn that lesson? Students? Hello? Can you understand why it is such important? Okay. Let me show you one. So this one, what is this? If you are a really good chemistry student while you are in O level, you might remember this one. What is the name of this gadget? Huh? This is a watch glass. What is this? This is a watch glass. Okay. Now, just imagine by completing it in your mind, if you complete it, it will be a nice sphere like this. But the problem is you can't physically measure the radius. That is why we are going to use our small gadget. I will tell you. I will tell you the method. I will tell you the method. So you can, Vishan, you ask the question. Oh, okay. So now I will tell you the method one by one. Have a good look at. You have to hold it like this and lower the pin of this one until it to touch, and there will be a reading on this one. Using this reading, you are just going to find few millimeter reading on this very small reading. Actually, using that such a small reading, you are going to measure the curvature of this spherical surface. So that is why I told you this method is kind of like semi-complicated, not extremely semi-complicated. But if you can understand the mechanism of what is it called, screw principle, the rest of the story is going to be very easy. Okay, I will tell you one by one. Okay, first of all, going to study this one. My finger, just half an hour ago, actually you would be really surprised to hear what happened to this half an hour ago. That's why I took a little more time to join to the class even. I tried to find something in my mother's handbag, like certain key. While I was trying, I felt an immense pain. It is actually untouchable, this region. So I put my hand out, then I could see there was a small Panadol card which could cut entirely my nail to the very end until to this region here, completely cut. It's really painful. So see, small Panadol card could do that. That's how the life is. That means if somebody used the Panadol card, even can kill a person. Even I just learned that. Okay, now I am going to disassemble this device and show you one more time. I showed this one in the last week even. Let me show you. Right, I disassembled. Now have a good look at. This is the screw. It is like a screw ball. Let me hold it like here. This part is a screw bolt. Okay. This part is a screw bolt. This looks as if a screw bolt. Okay. So this is the nut. And let me show you one more thing. This part is as if screw nut. So I can put this in and happily rotate it through, and it will run through this one. So each complete revolution, it will go complete the distance of one of these thread, two difference of two threads. That means the pitch length, right? And you have to remember one more thing. In the micrometer screw gauge, the scale is in the anti-clockwise direction, but in the this one, it is in the clockwise direction. Okay, I will explain you one by one. I think now it is the time to start Spherometer concept. Okay, now write a very big topic. Spherometer. Spherometer. When is the exam? Means your exam, your A-level exam. You are asking about your A-level exam. Then you are talking about our test. Our test. It will held within like 30 days from here. Within like 30 days from here. And the winner will definitely receive this one, no, micrometer screw gauge according to his or her preference. Real one. Okay. That's the gift. And also I want to declare another thing. So we decided to launch something that is called top performer of the month for all our subjects. Top performer of the month. Top performer of the month means the one who get maximum result in the test. End of the month, there will be a very short test. End of the month test. We choose someone as the best performer. And also we give another title that is called best contributor. What is the difference between best performer and best contributor? That means there are certain students who actually bring students to this class. So sometimes only one student will be newly added, only introduced by one student. So he or she will be the best contributor. We just discussed in the yesterday actually. Teaching first staff just gathered together and discussed about this because everybody really like to get their appreciation for their hard work. Doing test really well mean you performed very well. You deserve to get something as your motivation. So that's how it is. Both categories will be evaluated. Okay, now we are going to learn Spherometer principle. Write the big topic. Spherometer. 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 Okay, write it like this. Spherometer is an instrument. Spherometer is an instrument used in used in used in measuring. Used in measuring. Measuring what? Used in measuring and calculating. It is not direct measurement, so that's why measuring and calculating radii of radii of spherical surfaces. Radii of spherical surfaces. But remember one thing, that is not the only purpose. There are some other purposes as well. So write this in a new line. Radii mean we call radius for one object that can be a circle or sphere, one radius. There is another one. So plural word for radius is not radiuses, it is radii. Okay, different surfaces. You are measuring radius of each. So that's why I call radii. Difference mean you can measure multiple different surfaces and their radius on radius. So radii mean different radiuses. There is no word called radiuses, but for your understanding, I said like radiuses. Okay. Right. That is the main reason. That is the main purpose we are using it. But we have to use it for some other purposes as well. Sometimes you can measure the thickness of a small glass slide. And sometimes you can measure something like a small hole, depth of a small hole, more accurately than depth gauge of the vernier caliper. So we have to learn each separately. Don't worry, I'll teach one by one. Okay, Ramai. Now write this topic. Parts of a spherometer. Parts of a spherometer. Have a really good look at. Don't draw this one. Don't draw this one. It will consume your time. Right. It is a very simple device. And also there is a vertical scale. Right. It is a very simple device, but you can just kind of like, what happened here? Something happened with this one. Wait. Right, Nick? Okay. You have to draw the diagram in the page number 23, I remember. Give me 1 minute. Here. Give me 1 second. Make sure that you draw this image. This is very nice one. In the page number 23, this looks very nice. Take your time and draw it. But it doesn't matter if you draw this one, even if your drawing ability is very bad. But try to draw this one. This looks very nice. Take your time and draw. Right. Not now. At your home, do it as a homework. Right, my students? So I can consider this one as a leg, just a leg of a spherometer. And this middle part as middle screw. Middle screw. And here circular scale. Scale. And here this one, we call it like vertical scale. Vertical scale. Sometimes you can call it like main scale. Right? And this part is normally called like head. That's it. This is a very simple structure. Not a big deal at all. Okay? This is not a very big deal at all. And give me another second. So this spherometer is a real one, right? But this spherometer, just I tried to make as a demonstration kit. I told you I just ask a certain welding dude to make some kind of like dummy spherometers. I actually made something even nicer than this. I gave him to make it, but he just failed to do it. And I don't know how to handle those machines. Otherwise, I can make it. So this is a real one. This is like a dummy. If you have a like kind of like good crafting skill, you can make your own spherometer and keep that on your table, right? And show me if you can make a one, right? Show me a picture of those things if you can make a one. Take it as a challenge. It will be really nicer when you study. There is a dummy of this one on the table, right? Because the physics is something like you have to go along with innovations. Try to do something like this type of dummy. Anybody can make it. Anybody can make it if your brain is really functioning well, right? Okay. Now have a good look at. I will show you this one with the real stuff. See the legs, the middle screw, and the circular scale, and the head, and the vertical scale. Very simple structure. Now write how to read a how to read a spherometer. How to read the spherometer. Okay. Firstly, write the vertical scale. The vertical scale consisting a millimeter scale as in the diagram given below. Have a really good look at. It is a millimeter scale, but weird one because 0 is in the middle. 0 line is in the middle. 1, 2, 3, 4, 5, 6, 7, 8. It doesn't go for many millimeters because it is a very small readings you are taking. 2, 3, 4, 5, 6, 7, 8, something like this. You can read it upward as well as downward. So copy this one consisting like this. Okay, before that, I want to ask you a few questions. If I hold my pen like this, what is the reading? What is the reading? No, 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 yes, okay, yes, Mohinder correct, Tejan correct, okay, Tejaspin correct. Mm-hmm. Hey, dude, you can't go for like point values. How can, oh, Pehan, oh shit. Two of my best students say like that way. How can you read 0.5 value in here? Is that marked? Is that marked in the main scale? I told you you can't never read anything. It's not if it is not marked in the main scale. It is completely forbidden. You can't say it like 3.5. But you can only say it like the main scale reading like this. It has gone past 3, below 4, but still you can say it like 3 millimeter only. 3 millimeter only. Understand? You can never say it as if 3.5 millimeter. Okay? Because 0.5 is not marked. Just use your brain a lot. Okay? Use your brain a lot. Right? Now have a good look at. I'm going to erase this. Remember one thing. Now write. No, don't write. So now I'm going to keep the circular scale like this. Okay. I have to tell you and show you one thing. See very carefully. Now see. Let me hold something as a background. Okay. Here. Wait. Here. See. No. Even it is much closer. You are not considering it like 3. See. It always come up like this. The vertical scale here and the circular scale act as if a indicator for the main scale. Okay. Circular scale act as if the indicator of the circular main scale. Can you understand it? Can you understand what did I say? Circular scale act as if the indicator. Okay. So it shows the direction of the what? Main scale reading as if an indicator. Now copy this one and write. Did you copy this one? Let me know. Did you copy this one? Okay, copy it quickly, please. Copy it quickly, please. Students, now have a really good look at. It is going to be what? Now write. The circular scale act as if an indicator for the main scale reading. Main scale reading. Here, what is the reading? Reading is 3 millimeter only. Okay. Right, my dear students. One student just asked me something. If it is way closer to 4 millimeter, this is the third line, this is the fourth line. She asked me if it is very closer to the third line, fourth line. What is the main scale reading? Tell me. What is the main scale reading? Everybody, tell me. Is that 4 millimeter or 3 millimeter? You can say any of the answer, it doesn't matter. According to your understanding. Somebody can tell me it is 3 millimeter, somebody can tell me it is 4 millimeter, it doesn't matter. I don't mind. Still 3 millimeter because you have only take the main scale reading. If it is small shorter, still shorter, it is what? 3 millimeter. So I am like 5 foot, 11 and half, and actually closer to 6 only by 1 centimeter short. Am I a 6 foot? Only a 1 centimeter. But no, I am just 5'11 here. Okay. I can't say because why? It is just 5'11. internationally, yeah, if your birthday is tomorrow, if your birthday is tomorrow, you are about to turn into 17. But you can't say like you are 17 yet. Why? You are still a 1 day behind. Normally, like international standard, you are still 16. Yes, then the reading will be not accurate. So there is a method to find out the difference between here and here. Okay, 3 and 4, the line is very closer. We have to find out this distance x, unknown x, distance x. How are we going to find that? That is when this circular scale helps us to find the missing part. Understand? Circular scale will help us to find that missing part. Okay. Right. Now write like as if this. How to read the circular scale? How to read the circular scale? Okay. Before going for circular scale reading, I would like to test your understanding. Just understand. There is the 10th line. I want to check the reading of this line. What is that reading? Is that 12 or is that 8? Is that 12 or 8? Okay, Vidushana correct. Others? Hasan correct. Others? Sanas? Others, my dear students, hello. Yes, Pehan, with the reasoning even. Tejaswin correct. Tejan, we think. Insulini, we think. Lydia correct. Lydia correct. Okay. Yes. Because, dear students, I said it is clockwise. So the readings are in the ascending order in the clockwise. So this is 8. This one is 12. So sometimes MCQs may come in this way to distract you. They will only show a certain number, asking a number above or below. If you just forgot, Spherometer is marked in clockwise direction all over. So every single bit of knowledge is important. Okay. Now write this in here. When you observe circular scale from above, it is the 30th line. It is the 30th line. You have okay. What is this? Circular scale. What is this line? Main scale. So I am going to show you that one too. Now see, when you observe this from the above, you can only see the face of this line and the spherometer here. Understand? So this one acts as if the indicator for the circular scale reading. Right? You read it compared to this point. Understand? Is there anybody who couldn't understand it? Do you need me to explain? Hello? Do you need me to explain? Okay, okay, okay. Uh, there is a very, very old DVD. I use this since 2023 batch. It, it is all marked in the clockwise way. See? 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So I told you, when you are just observing, it is all given in clockwise. You rotate it anti-clockwise to move it up. Okay. Now have a good look at. I need to find out the ruler. Okay. This ruler acts as if the main scale. Okay. Now see. So now, what is the reading? This looks nice, you know. What is the reading? Huh? What is the reading here? It is 30. Okay. Now see, it is, what is the reading? It is 50. Now reading, what is the reading here? 90. Understood? Everybody? See, certain and old DVD can lead you to understand everything. Okay. So now this one acts as if the indicator. So is this source, this line over here. So now what is that line? Can you tell me the reading? Now use your brain and tell me the reading. Tejaswin, good boy. Vidurusana, good girl. Pasan, good boy. Charaka, good boy. Lydia, good girl. Tulki, good. Tejan, good. Sanas, good. Everybody seemed to be really good. Nobody just gave me wrong answer. This 28. You have to read this as if the same way of like what? Behind good. Same way like micrometer screw gauge. So your reading would be circular scale reading. CSR. But we know something CSK, no? Chennai Super Kings. You can just remove this part and it looks like CSK now. Okay. CSR. Circular scale reading. This one. Number of parts multiplied by please count. Very, very simple. Very, very simple. I used to watch IPL, but I know it is like a fixing. But still, I like some players I watch. Rarely, not daily. If I feel like watching, I watch. Normally, like Dhoni is a good player. I really like him. Kohli and Josh Butler, many, but no Sri Lankan player. Here is 28. When Sangakkara, Mahela, Dilsan were there, I really loved them. Now there is nobody. So the reading is 0. 28 millimeter. Copy this. Copy this quickly. Copy this quickly. Now, do you like any player? My problem is, do you like any player in current Sri Lankan team? They are talented players, but no discipline. There are talented players, pretty sure. Vandu is a really good talented guy. Mahish is a talented, but no discipline. So why do we like them? Padirana? No man. Padirana is a good guy only with Dhoni. Okay, that's it. Okay, now let's get an example. Now read this and show me. Let me draw it very closer to fourth line as a tribute to that student who asked me that question. Okay, very closer to fourth line. Okay, this is the side view. So I'm going to draw the top view. Top view. Just 85 line is coinciding with each other. Top view. Now tell me the collective reading here. What is the reading of this device? Yeah, Vidursana, like a rocket. Sharaka, very good. Now people getting used to Fasan, very good. Are you Fasan? No, Fasan. Dulki, okay. Fasan, okay, okay. Isara, okay. Fasan, Fasan. Okay. Lydia, okay. Okay, everybody correct. Now see, very simple thing. Reading equals to main scale plus circular scale reading. So the main scale is 3 millimeter plus the circular scale is 85 times 0.01 millimeter. So the reading will be 3 millimeter plus 0.85 millimeter. So the reading is 3.85 millimeter. Understand? I hope that everybody understood it. Ne? Okay, correct. Great. Copy this. Okay, Lamai, quickly. I'm going to erase. Okay, Lamai. Now, right, this is a little bit tricky, not extremely, little bit. Now, right, uh, taking a reading below the zero line. Taking a reading below the zero line. This is going to be rather nice and tricky. Nice and tricky, not hard. Nice and tricky. Let's see what is that nice and tricky thing. Okay, have a good look at here. You are about to read something lower than zero line. Okay, tell me what is the main scale reading? What is the main scale reading? Everybody? Everybody? Huh? What? Huh? Mono? And? Oh, man. I feel like just jump onto somewhere and say goodbye to entire the society and go into a very big jungle and disappear over there. I can't imagine the numbers you said. You just read it like 1 millimeter. You just read it like 1 millimeter. Reading is 1 millimeter. You can mark it like downward, indicating it is downward 1 millimeter. Not -1 or +1. It is like 1 millimeter downward. That's it. No, 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 no. No, no, that can be negative, but we are not using any positive or negative. You will understand very sooner why it is. This is completely logical. Completely logical. Okay? Right. This is not the biggest logic. Now write. Now write like this. How to read. How to read circular scale. How to read circular scale. How to read circular scale for a reading below zero line. I hope you have copied this one. Now it is going to be really very, very little bit tricky. Now imagine as if it shows the 20th line. It shows the 20th line. Okay. 20th line. This is how it is. Now I have to show you one more thing. Let me mark this big screw. Big screw. Students, have a good look at this big screw. Okay, Pasan. Okay. This big screw. If I want to unscrew. Unscrew mean just wait. I have to put it. So more unscrew. That means I have to just move it upward. To what direction should I rotate? To the clockwise or anti-clockwise? To the clockwise from here or anti-clockwise? See, I'm holding as if to you to see. To anti-clockwise like this or clockwise? Definitely anti-clockwise. Okay. If you are taking any reading below zero, below zero, below zero mean you have to tighten the screw. You have to tighten the screw. Can you understand? To where you should now rotate? Huh? You have to rotate. It is in clockwise direction. I keep rotating it clockwise. Now you can see it is moving further down. So you can see the length of this part in piece. Ne? I am going to rotate it in clockwise now. Okay. Now if you want to take any reading below zero line means you are rotating in the clockwise direction. Have a good look at. Now I am going to rotate this clockwise. 0. Okay. Sorry, I actually rotated in the anti-clockwise direction. Sorry, because I was watching as if a mirror. Okay. Now you can see 80 as the reading. 80 as the reading. Is that fair? I'm asking, is that fair? No. Because why? It has only rotated some 20 readings, but it shows as if 80. That is not fair. How to get the actual reading? Hmm? How to get the actual reading? It is like 20. If it shows like 20, now let's rotate it until to it to show 20. Okay. Now it keep rotating, not finding yet. Now just found. It read as if 20, but I have almost completed the one cycle. So what is the reading it should be? Is that 20? That is 80. Understand? So you have to take the reading as if what? Circular scale reading is capital N is 100 for this case, minus simple n times least count. Copy that equation and let's apply and find out. Now write it like CSR 100 minus 20 times 0.01 millimeter. So your answer is 80 times 0.01 millimeter. So the answer is 0.80 millimeter. Very, very simple reading. I'm sure you understood it. Okay. Students, you understood it? Yeah. Okay, now take the reading. Reading is 1 millimeter plus 0.8 millimeter. So my reading is what? 1.80 millimeter, which is downward. We only mark it like upward or downward. Okay, students. Now I want to show you something very important. All right. Checking for initial reading. Checking for initial reading of Spherometer. Checking for what? Initial reading of a Spherometer. Initial reading. What is the meaning of initial reading? Initial reading. Why? There is no zero error in the Spherometer. We are not talking it like a zero error. We read it as if initial reading. We subtract it from the final reading. Yes. Collects on the. I have to show you. Oh, shit. Give me a 1 minute. Me to bring the glass block. Okay. So you have to just keep this actually on a table. I don't have a table that has the height closer to my chest height. I just actually asked a kind of like carpenter to make a table that adjustable until to my chest height. To show you these things, it will be like finished within like 2 weeks from here. So you have to just keep this on a table first. Now you may see as a kind of like what shadow. You can see the legs also on the shadow, isn't that? See, you can see the shadow. Ne? Okay. You have to observe the shadow and keep this lowering until to this tip of the middle screw to in contact with the glass surface. Now you have to keep observing what the image. No, no, no. I am going to tell you why we can't use a mirror even as a theory. Okay. Now you can see the image. Still there is a small gap. See, in the image you can see there is a small gap. You have to just move it until to it to in contact. Now it looks as if good in contact, but I'm not sure. So I have to check it. So actually, I have to use an oil paper, thin oil paper. So I had a one, I can't find it. Now I have to try to slide this, but small oil paper through it. It does not move. That means this is in contact. Okay, this is in contact. I have to take the reading. It is like 2. 2 in the circular scale reading. That means 0.02 initial reading is there. It is a positive one. Positive means an upward reading. An upward reading. Okay, you can't see it. I don't know whether you can see. See, 2 lines above. So that is how you are going to check. See, you have to check for the firstly the image. Image means it is like a partial refraction. there's a thing called partial reflection. So if I ask you a question, sometimes even I still do that. In your age, you keep always doing that. When you are just about to feel don't feel good with your hair, you just find something and just make your hair in the right position. That's a habit for me. I always do it. Okay. Sometimes all the time you are not finding a mirror, but when you are just walking closer to any wall, right? You also that's also any boy's thing, right? Closer to a window, you can see very vague image of yourself. Car glasses, yes, and any vehicle, the glasses, you can see some kind of distinguishable image of yourself, and you just look at it and you make your hair back into the right position, right? So here also it create certain image like that. That is due to the partial reflection. Not not about when the girls are there. I do you do always when the girls are there only. That is a habit for me, right? Even I am alone. If I don't feel really good with the hair, I just do it. I have seen many boys do that, even girls. Okay, this is the thing. So you have to coincide the real screw and the image of the screw in contact with each other. You asked a good question. Why we can't use a glass mirror instead of this glass? I'll tell you why. Okay, I'll tell you why. I think you have completed all of this. I'm going to erase. Okay, my dear students, have a good look at. So for here, if you use the mirror, the reflecting surface is just beneath the upper surface. Now there will be two images. One is this paint image from this upper surface. It is a very indistinguishably paint. Indistinguishably. But for the main image, it will create, if the distance is from the upper surface to shining surface is like x, it will create the image another x distance downward. It will create it like in this way. So you will never be able to coincide these two, the real object and image. This upper surface make a paint image, but when there is the presence of a bright light and very faint light, you are not distinguishing the faint one at all. So you can't see this image even now. You can never coincide them alone. Can you understand why is the reason? Huh? Hello. 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 Okay. Now, right, how to check the initial reading? How to check the initial reading? Okay. Now, right, how to check the initial reading? Firstly, raise the middle screw. It is like this. Raise the middle screw. Okay. Now, the next step is place the glass block on top of a table. Next step is place the glass block on top of a table. On top of a table. Now what? Keep the spherometer on top of glass block. On top of glass block. This is table. This is glass block. And you are going to keep the spherometer. I'm only going to draw two legs. The middle screw is in between the two legs now. It has raised. It's just above the surface. Now draw it. Draw it. Draw it. Okay. Draw it. I think I gave you enough time. Now write. Now lower the middle screw. Lower the middle screw until it to touch with glass surface. Do it slowly. Do it very slowly. Okay. Now like how to check, how to check, how to check. Draw it first. I will give you another 30 seconds. 30 seconds. No. I will tell you the writing thing. I will tell you the writing thing. Now copy this. Copy this. I will repeat it. Don't worry. I said like lower the middle screw until to it to in touch with what? Upper surface of the glass. Do it slowly and draw it. Okay. And I said another thing. Now how to check whether the glass and the middle screw, glass and the middle screw are perfectly in touch. Glass and the middle screw are perfectly in touch. මේක හරියට ටච් වෙලාද කියලා බලන්න ඕන. Now we want to check whether it is completely touched. How can we do it? How can we do it? Have a look at now. Right. Write it in your line. Can do it just by observing, just by observing the images, observing the image of the middle screw, image of the middle screw, by observing the image of the middle screw, and the middle screw coinciding with each other, coinciding with each other. Now it will create certain image like this. Middle screw, image of middle screw. It is due to partial reflection. Okay. Okay, my dear student. Copy this one. You want me to repeat it? You want me to repeat it? Yeah. You can check this by the coinciding images of image from the upper surface due to partial reflection of the middle screw, partial reflection of the middle screw with the middle screw. You want me to repeat from where? You want me to repeat from where? Oh my God, I can't remember what did I say even. I can't remember what did I say even. Just keep a space and watch the recording and correct. Or I will ask one of my students to send their notes and forward it and keep some space, sufficient space for that. And ask me for the note, then I will ask one of my students and he or she will send me the note. Because I upload the recording to the group, ne? Didn't you see the recording in the last week? I upload the recording to the group link to the recording. Sorry. Oh, why don't you check the group, main group? In the main group, I put the links. I put the midweek worksheet. I send the drop what on the spot live worksheet. I have already dropped it for today. Then recording links. Everything is in the main group. We are not putting any link, any video, any image, something not relevant to our class. So we are sending everything relevant of our own class. That is not a chat group. That is the main group. You have to pay attention for that group every day. Before you to sleep, at least, just try to check your messages. Sometimes by mistake, your parents might check the group. I'm telling to everybody, yeah. So they check the group. You are not seeing the notification even. They have already seen. They have read the message, but forgot to tell you, you are not getting the message. So everybody, please check the group daily. We update you with an important information, midweek worksheet or whatever answer sheet. I send you the answer sheet even. I sent you like a hard question review recording even. And I also sent another second midweek worksheet with self-study. Self-study one came up with like the question and the answer and how to gain it. And at the end of it, there were like few questions. Students, don't miss out anything. I upload many things to the group. According to your work capacity, do you can do. If you send me only half done worksheet, I still appreciate. Why? I'm not expecting everybody to complete huge task, but if they can do only like 3 to 4 questions, no problem. Send me the answer sheet. I will happily check your answers. But I'm not marking the stuff. I don't have the time. But I normally check all the answers. If the student has done something wrong, I put them a voice message. You have done a mistake over there, but most of the students have done no mistake. So I only check like say, okay, you have done really good. You might think like, okay, this man has not checked. No. I check. If you have done any mistake, only I just let you know you have done a mistake over there. In the first lesson, it may look like your religions. So all the religious papers are really easy. Buddhism paper easy. RK paper is really easy. Like I don't know about Hinduism, it might be also be really easy. Whatever the religious paper is the easiest one. But upcoming lessons will be like really hardcore something. Even in the religion, hardcore of religion will be very hard. Like you only know the basics. It is like that. For the first test will be really easy. But I'll give you a tough one within like 30 days from today. Okay. But I will inform you the exam day like at least like 10 to 14 days before. I will tell you what type of things are coming and I'll give you like a mock test even that you can do it at home and see whether you are ready for the exam. If you are ready, then inform. Yeah, Abhidharma is very hard thing, no? But regular Dharma thing we used to know, we think like, we are mastermind in this Dharma part. But actually the Abhidharma. And like in Catholicism and stuff like it's called theology, hardcore, very hard. So physics also will be like that. But if you improve yourself day by day, that is why I'm spending a lot of time in this lesson and feed you with more concepts because I want to ready your brain for those lessons. Those people just follow what is the sir doing over there and they think like they have done, they have completed. That is not, my dear. Check. Most of the students get really low result. I don't want any of my student to get failed. So if you feel like, Ammo, this man is teaching very concepts I don't need, you can go. But remember one day, without concepts, you will badly suffer. So don't let it happen. Okay. Now, right, as a question, why can't use a mirror to check this? Why can't we use a mirror to check this? Firstly, draw this diagram and I will give you the explanation. I will give you the explanation. Okay. Write this. Mirrors always create images, form images twice of the thickness of the glass behind the mirror. So we'll never be able to coincide screw and the image of the screw. That's it. Oh God. Say again. Okay, I will say. Mirrors always form images a distance of twice the thickness of the glass. Behind the mirror. That's it. Okay. Now have a really good look at. Can you ever imagine in many classes, some classes, they have finished these things and they are in vectors, but they will spend a lot of time in vectors and linear motion because this region is really scary. What we did with the concepts, but with the sugar-coated method, I show you like 30-second example. 5-minute example in a one day. Yes, I have seen that. But the problem is, you can just manage it for now. These things, if I show you with the sugar-coated method, but within few months, your knowledge will be blank. Your knowledge will be completely blank. So to my 2025 class, 26 class, the physical class, one of the student from 25 batch who used to go to the one of the leading, actually he's the leading dude in Nigambo, and that girl from also Amaria Main, she just came only to cover the instrument lessons and vectors. The reason is why she has no knowledge, she has completely forgotten everything. If I show you with the sugar-coated method, you will forget the technique because they only teach you with the technique, not the concept. If you have the concept, you can do any question at any day, even after 3 years. Okay? Don't let it happen. Your hair length using vernier? Wow. Wonderful. Using depth bar. Okay. Have a good look at. Now right. So the initial reading is also read like a normal reading, regular reading, just above zero or below 0. And we add it or subtract accordingly. Add it or subtract accordingly. Imagine like if I just teach you like this in detail, still you understand some of the concepts after watching video. Ne? I give you all the explanation, demonstration, and everything, but you understand some of the parts even after watching the video. See, there are many really good concepts here. How to practice. Okay, have a really good look at now. How to remove in a cell reading. Write this. The following diagram represent certain reading, certain reading, certain reading, certain reading of a spherometer, of a spherometer, of a spherometer that has taken for measuring what? A thickness of coin, thickness of a coin. Now let me show you the circular scale reading. It will show you like 40. Right. Write this in a new line. It has an initial reading as following. An initial reading as following. Initial reading. This is the circular scale reading. Now write. Find out the final reading. Final reading. Final actual reading. Final actual reading. Right. Start it. Take like 2 minutes maximum and do it. Take like maximum of 2 minutes and do it. Did you find any answer? Yes, Tejaswin. Vidusana? Mm-mm. No, 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 no. Tejaswin is correct. And one another student correct. I can't remember his name. No, no. I'm asking the actual reading, whole reading, whole reading, whole reading. Tejan, no. This is the initial reading. This is the final reading of main scale and the circular scale. No, no. Charaka correct. Charaka correct. Charaka correct. Charaka correct. Mm-hmm. So I actually let you to think yourself and do it. Lydia, very good. Good girl, correct. Tejan, no, no, no. Right. Have a look at. Have a good look. This is something like a building. This is the ground floor. This is the ground floor. First floor, second floor, third floor, fourth floor, fifth floor, sixth floor, like seventh floor. Underground floors, first, second, third, fourth, fifth, like. This is the ground floor. That means the zero. Okay. Have a really good look at it. Right. You are in this floor now. Your initial position. Your x1 position. Your x1 position. But you reach to there from here. You reach to there from here. First floor. You reach to there from the first floor, first, second, third, fourth, fifth. How many kind of like floors you had to climb up now? How many floors that you had to climb up now? How many floors that you had to climb up now? The final result. Yes, Pasan. Correct. Okay. Sejan correct. Tejaswin. Okay. See, this is your initial position. You started from here and you got in instant call from your boss. You reached to the fifth floor. How many floors you had to climb up? Only four. Understand? Only four. Because you reached to there from first one, two, three, four. Not five. Why? You were in first floor already. You reach to there. You only have to climb five floors. Sorry, four floors. Can you understand? Can you understand? Okay. Now the situation will be different if you started it from a different floor. Now you actually started to move there from third floor, just underground. You get a call. You have to climb up. Even in an elevator, how many floors? Now you have to go. This is your final destination. This is your initial position. X initial. How many floors now you have to climb up? Huh? 7. Okay, let's see. You start from here. 1, 2, 3, 4, 5, 6, 7. 7. 1, 2, 3, 4, 5, 6, 7. Ah, yeah. Yes. Okay. This is actually not the third floor I have drawn. That's the problem. That's the problem. Ground floor is this one. Ground floor is here. Sorry. Ground floor is here. This is the third floor. See, it is 8. 1, 2, 3, 4, 5, 6, 7, 8. Now you have to climb up 8 floors. Can you understand? If your initial position and final position are in two ends, initial position is below the zero and the final position is above the zero. Now you have to do what? Add them. But if the initial position is also above zero, final position is also above zero, you have to subtract them. Understand? Understand or not? Because I have seen some of the students come up with like kind of bad situation with spatial recognition. But if you don't understand the spatial recognition well, just drop a message. I will re-explain without telling your name. Do you need me to explain it? If yes, okay, I will explain it. I will explain. Now, have a good look at. This is the zeroth line. You started somewhere here. What is your initial reading? Initial reading is 15 by 0.01. So the initial reading is 0.15 millimeter. Your starting point is what? 0.15 millimeter. Right. Your final reading is what? So final reading is 2 millimeter plus 40 times 0.01 millimeter. So 2.40 millimeter. Okay, let me mark it 1, 2 here. Your reading is 2.40 millimeter. Now see the gap. The actual reading should be this gap. Isn't that? Actual reading is not 2.40. It is as if, like I told you in the first week. Can you remember when I take my height? Right? If I just take it from the ground level, it is what? The real height. If I just take my height from standing on something, it is like here. See, now I feel very taller, right? Because that is not my actual height. I have to subtract it. Right? So the difference here is 2.40 minus 0.15 millimeter. Can you understand it or not? Understood, no? Is there anybody who can't understand it yet? Please let me know. This is very essential. That's why I'm asking. You. You still don't understand? Okay. Okay. Forget about it. Forget about it. The problem is not your. You have not get the concept of number line. You have not get the concept of number line in your grade 6, I think. 0, 1, 2, 3, 4. You started your number from number 1. You finished at number 4. 1, 2, 3. This is how you do. What is your result? 4 minus 1, it is 3. Can you remember you did something like in your number line? Huh? Yes. And by the way, you are going to start it not from here. Now you are actually starting it from minus 3, minus 2, minus 1. You actually started from minus what? 3. You started from minus 3. What is the difference now? Haven't you done this thing? 1, 2, 3, 4, 5, 6, and 7. What is your final result? 4 minus 3, and your result is like 7. You have done this thing in your grade 7, no? Isn't that the same thing that we have to apply over here now? Huh? Yes or no? Understood? Okay. So let me write the final reading of this one. Final reading is, actual reading is 2.40 millimeter minus 0.15 millimeter. So the reading is 2.25 millimeter. Okay, copy that. No, no, no. It is not main scale 0 reading. When we check like this, when all the 4 legs are in touching with the, yeah, that's what I'm telling you. When all the 4 legs are touching with the glass block, if it is solving what? Any reading over here, if zeros are not coinciding, there is an initial reading over this one. Can you understand? It is like a 0 error. But we don't call it 0 error because why? It is an error. It is like a 0 error. But we can't call it like positive 0 error or negative 0 error. Why? We always take difference of reading from this device. That is why I told you spherometer is a little bit tough one. Little bit, not too hard, bit tough. Okay? Understood? Initial reading means a 0 error. You can understand it like a 0 error. That's it. But we don't call it as a 0 error. Main scale reading can be 0 as well as 1. Who knows? In here, only given circular scale reading. That means main scale reading is just still the 0. If it is not specially mentioned. If the main scale reading is not specially mentioned, that means it is 0. Is that what you asked? Yeah. Figure 15 means circular scale only has moved somewhere just up. See, somewhere just up the, just above the zero line. Okay. If you show the main scale reading, it is still showing the zero line. Okay. Understand? Very simple thing. Okay. Now have an interval and quickly come back. We have to do a lot of huge tasks. ගොඩාක් වැඩ තියෙනවා කරන්න. Have an interval about 12 minutes. So join back about this time. Right? We have a huge task to do. Okay, dear students, enjoy your interval. Hi, students. I'm pretty sure you are here. Confirm me whether you are here. Hello. Confirm me whether you are here. Jahan is there. Vidusana. Dulki. Movindi. Sanas. Charaka. Pashan. Okay. I think most of you are there. Now we want to go for something really important. So I will explain you the previous part one more time. One more time. One more time. Without any diagram. Without any diagram. You get a reading upward, which is like 2.6 millimeter. 2.6 millimeter. And you again get an initial reading. An initial reading or the error, actually an error. Error of the instrument. That is 0.25 millimeter. This error above, and you again get the same type of error but 0.25 millimeter just below. Now how can you make the correction for these two? For the first scenario, for here, what can you do? How can you remove that initial reading? Now tell me, by adding or subtracting? Just the answer of adding or subtracting. That's it. I'm talking about in the first scenario. Yeah, correct. Fasan, correct. subtract. You have to subtract. That means the actual reading is 2.60 millimeter, subtract 0.25 millimeter. The reason is both of them are in the same side. I said, if you feel like you forget, just write this point. Write this point. If both the readings are in the same side, if both the readings are in the same side, if both the readings are in the same side, how to subtract? How to subtract the reading? How to subtract the reading? Okay, how to subtract the reading? If write this in a new line, if initial reading and final reading are opposite sides of, if initial reading and the final reading are in opposite sides of above the zero and below the zero, how to add? How to add? Have a good look at here. The actual reading 2 is 2.60. Now there is a lower reading of opposite side. That means you have to add 2.85 millimeter will be the answer. I'm sure you can understand this. Okay? Sure you can understand this. Ne? Hello? Copy these two. Now we are about to start how to measure inner circle, inner diameter, sorry, radius of, outer radius of a spherical surface. Now write how to measure outer radius of a spherical object. So outer means this thing, huh? From above. You are measuring it from above. So inner mean you are going to measure it from putting it inside. Okay. These are two different things. For eye level, we only need to find it out for outer diameter. Okay. This is the spherical part we have. I will just keep the spherometer like in this manner. There is a third leg as well. I'm not going to consider that one. This is where the radius is. This is where the radius, sorry, center is. What is this? Capital R, that means the radius. If you draw any line from circumference to the center, that is radius. This one is radius. This one is also radius. Right. I want to show you one important thing. One important thing. So now I am going to keep this spherometer on top of it. Actually the fake one, not the real one. Okay. Now you can see it will just keep in touch with all three legs like this. If I mark the initial positions, let me mark. I'm going to mark the initial positions. This here, and the other one here, and the center is here. Okay. I have marked all three legs like this. Now I am going to complete the path. You can see now it is as if a circle. It is as if a circle, isn't that? So see, if I slice this, this edge make a circle, no? This edge make a circle, isn't that? This spherical surface, but this edge makes a circle. If I cut it through here, won't it make a circle? Won't it make a circle? Huh? It is a circle. Now I can just make a line. It will make a radius of that circle. This is the radius of what? That circle. Radius of that circle where you keep all three legs like this. Okay? Where you keep all three legs like this. Do you understand it or not? Do you understand it or not? If not, let me know quickly. If you don't understand, let me know quickly. Okay, I'll repeat it. When you keep all these three legs, okay, on the surface, you can draw a circle on that, isn't that? So this circle makes a radius R. Don't you understand it? Don't you understand it? Huh? Okay. That radius is here. Okay. Now have a good look at. We can only measure this height from this spherometer. We can't measure the radius, but we can measure this height. This height is just simple h height. What about this length, the remaining length? It is r minus h. Can you understand? We can get capital R radius minus the height we take. The height we take in the mean like this. If I raise it to a certain height, I can take that reading. See, there is a certain height it has moved. Let me move it furthermore for you to see. See, You can only measure this height from the spherometer. Can you understand? You can only measure that height, right? And if we assume this make, can you repeat? Send that message again. Copy that and paste and send me. Copy that message and paste and send me. I only could. Yeah, that is for the initial reading. But when you are taking spherical surface, hmm, there is one of my old cricket ball. Okay, I will be able to show you now. Now see. Now, if I want to balance on this ball, I have to raise it, isn't that? Now it is balanced. Can you understand? Can you understand what I'm talking about? Hmm? Can you understand? Ah, you have to raise it. You can only read this height that it has raised. Okay? I hope you understood it. Oh yeah? තේරුණාද? Understood? Good. Okay ළම කිව්වා. Okay, my dear students, copy this diagram. Copy this diagram. I can mark it like A, this point as B, this point as C, this point as O, center O, and this point as D, A, B, C, D, and O. Copy that. There's a new cricket ball. This one will give you a proper idea. See, now, okay, I'm going to keep it. Now only the first three legs are balanced. Now I have to lower it. Okay, now it is balanced. See, now you can clearly see the middle screw is just above other three legs. Understand? Understand? Yes or no? Hello? It gave me nearly, yeah, nearly 5 millimeters. Read. See, it gave me nearly 5 millimeters. I used to be an all-rounder, but I really like bowling. I really like bowling because I want to bowl as fast as I can. I did really well, but I did some stupid thing came along with cricketing. It is not stupid. Fast. I said like as fast as I can. How can I bowl as fast as I can when I bowl spin? But one of my role model was guy called Justin Langer. He was a good batsman, and he was also not like Malinga. My accent is more like Sean Tate. You might not know him. An old Australian cricketer. He retired about 2016, I think. My accent is almost like Sean Tate. It is bit slingy, not as slingy as Malinga, bit slingy, like this much. exactly like Sontek. So somehow I did taekwondo as well, and also football altogether. One day I got my hip crashed while practicing heavy taekwondo stuff. Then I couldn't continue taekwondo, I couldn't continue football, I couldn't continue cricket even. Then thankfully it happened just 2 months before application for the universities. So I had the second option of keep continue my studies. If it happened like 2 months later, I would be helpless. Then I can't play cricket even. I can't go to university. Then it would have been a very big tough scenario for me. But all happened in the right time, right place. I thought like this is my path. I'm really happy. Okay. Okay, guys. Okay. Now there is an equation. There is an equation. Okay. There is an equation to calculate the radius. Let's quickly apply to that and see how the radius come. Okay. Okay, dear students, the equation is r equals to a square over 6h plus h over 2. This is the equation. R equals to a square over 6h plus h over 2. Now you know what is h. This h is 5 millimeter. I took it from the spherometer. That is the only thing you can take it from spherometer. Now, what is this A all about? What is this A all about? That is also from spherometer, but that is a constant reading, not changing. Have a good look at. I told you, you keep that on a circular path if you construct. But we happen to assume this as if an equilateral triangle of one side of length A. Right. How to measure that? I will tell you how to measure that even, but I will measure it for just for, where did I keep the ruler? I'm nearly going to measure, nearly, it is nearly like 3.2. This is nearly like 3.2. Nearly like 3.2. Okay, student, A length is nearly like 3.2 centimeter. Right. Now I am going to apply this value to the equation and going to calculate the radius. Let's see. 32 square. Why did I put it 32? I want to convert it to millimeters because I can't use two different units in the equation. It is not good. Divide by 6 times. Height is like 5 plus 5 over 2. Okay. 32 square. It is nearly like 32 by 32. So 4 and 6 and 6 and 9. So 4, 2, 1 gone and like 10. So did I make it correct? 64 and 6 and 9. 4. 2, yeah, 1024. Answer is 1024. I'll keep it like 1000. I will round it up to 1000, right? For my convenience, I round it for 4000. And here, this is going to be like 30 plus 5 over 2 means 2.5. Okay, 100 over 3 means 33.3. Answer is 33.3 plus 2.5, nearly like 35.8. I can round it up like 36. 36 millimeter. Right? Okay, let's see whether it is true. See, I nearly get the diameter very closer to like 7.5 centimeter. So let's take it in the other side without removing the seam. Yeah, it is nearly like 7.5. When you divide 7.5, you nearly get something closer to this answer. That means 72. 72 millimeters. 76, sorry. 76 millimeter means nearly like 38 millimeter. So my method is very much of close, no? Can you understand? This is how we are going to measure radius of a spherical surface using spherometer. Understood? Everybody, tell me. Oh, okay. Is there anybody that who couldn't understand this? Is there anybody who couldn't understand this? So sometimes can be someone who was thinking, eh? Was just spinning a ball all around. What the heck he was doing? Might be. Hello? Hello? Understood or not? You are alive. Happy to see that. I don't like you guys are dead. Or converted to zombies all of the time. Hello? Got it? Okay. This is the competence level expected in A level. This is the competence level expected in A level. Okay? A level. But I have seen some of the, yeah. Yeah, it is the only reading you take using the what? Spherometer. See, this whole, every other thing is constant, no? A for this spherometer, it is a constant value. Where is my spero? See, distance between the leg is constant. See, 6 is a constant, 2 is a constant, only h is the variable. Only h. This height is the variable. See, this height is the variable. You have to put that. That is the only confidence level expected in local level. But if you feel like, and I have seen some of the teachers teach how to derive it. If you would like to, I can show you the way how to derive. But remember one thing, in the exam, they never ask it. If you like, I will teach. If you don't want, I will just drop a video. Oh, I can just drop a video of that, whatever. They never ask the derivation in IA level. But if you'd like, if you really love to see it, I can teach it now. What do you think? Teach it. Okay. If you want it, I will teach. Derivation. Because most of the school teachers may teach, you won't understand it even. It's going to be like a headache then. But for our syllabus, this is not expected. First of all, copy this diagram, please. First of all, copy this diagram, please. What did you write? What did you write? You just dropped a message and I couldn't see. Hello? Send it again. Telling a story. No. Today we have to finish this lesson somehow. Okay. I normally tell stories when it is not an intense. If I teach this part in 2 separate days, you won't be able to catch up. So I have to teach this somehow today itself. That is why I taught this like a train today, non-stoply. අද පොඩ්ඩක් කඩාගෙන ගියානේ. The reason is I wanted to finish the entire all this today. මම මේ බය ඉන්නේ බැරි වෙයිද කියලා. So help me to do that. In the next week, I will definitely tell you some stories and like funny things. Okay. But for today, excuse me for complete of this theory. Okay. Okay, have a good look at finish this quickly. Done? Done copying? Or couldn't copy? Done. Okay. I need 3 confirmation. Only one student said. Others? If I get 3 confirmation, I will start the next point. Okay. Other? Done. Adi. Now right. Applying Pythagoras theorem. Applying Pythagoras theorem to ABO triangle. ABO triangle. Applying Pythagoras theorem to ABO triangle. R square equals to what? Simple R square plus R minus H square. Right. You can see that you can use the spherometer and find out height. No problem. But these are, it is kind of like weird. To the center of the circle, how can you find? It is like really weird thing. So keep it like equation number 1. No, wait. I'll expand it. R square equals to R square plus R square minus 2RH plus h square. Because why? It is like p minus q square. How can you write? O level max. P minus q times p minus q. So what is it? O level max. You multiply it by p. Again by p. So right, your answer will be like how? P square. P by p. P square. P by q minus pq. Right? Now q again q by p again minus pq. Now q by q plus q square half. The same theory minus 2pq plus q square. The same theory instead of p here there is the r square minus 2rh like this like 2pq h square. Okay, right. Now you can cancel these two off. R, sorry, 0 equals to r square minus 2rh plus h to the power 2. Now you can bring this exactly back to here. 2rh equals to r square plus h square. R square plus h square. Now see, you want to find out r. What you are going to do? R square over 2h plus h square over 2h. Now 1h gone. So your equation will be like r equals to r square over 2h plus h over 2. But it is not finalized yet. Why? You have to remove this simple r from the equation because you can't deal an equation with two unknown terms. You can only use one unknown term, that is r. Because h you can find, this simple r you have to immediately remove. Can you understand? Now copy all of this. This is not the final answer, that's why I put it like x. Copy all of this. If you are mathematically kind of weak, copy this one somewhere. And if you are mathematically strong, don't copy these things. This derivation is completely not going to ask in the exam. But if you like, let's do. Okay, Ramai, quickly. Tell me whether you have finished this or not. Finished. Vidusana is very fast, no? Others? Finished. Okay, Sanas. Done. Good. Now, right, to remove simple r from the equation, have to follow the following path. Okay, have a good look at. It is like x, y, z. Three legs. When you keep three legs like this. Okay, three legs like this. These 3 points. Now this is the radius R to the center. Okay. Now you can see this one as an equilateral triangle. Equilateral triangle. Okay. Now let me draw that triangle only. Each side A, this side is again A, this side is again A. Your radius is over there. Now what is the angle of an equilateral triangle? Because of a triangle, it is 180. Equilateral means all the angles are equal. So it's going to be 60 degree. One side is 60 degree. Now you have just bisected here. Bisect. This line will definitely bisect. Bisected angle is what? Can you tell me what is the bisected angle? It is 30 degree. Very good. 30 degree. Right. R. And it is 30 degree. Now what about this length? This length is A over 2. Right. Now finally I am going to get this small triangle. Small triangle. One side is A over 2. Here this is radius. This is 30 degree. Okay. What is this side according to trigonometry? This side is what side? A over 2 is what side? According to trigonometry. According to trigonometry. It is the adjacent side. Okay. This is hypotenuse. So what is adjacent side of hypotenuse? Cos theta. Okay. That is cos theta. So adjacent side is A over 2. A over 2 over hypotenuse is R equals to cos 30. We know what is cos 30 now. What is the value of cos 30? If you can remember. Huh? What is the value of cos 30, my dear? It is root 3 over 2. Okay. A over 2 R equals to root 3 over 2. This will cancel off. Now you can find out R. What is the value of R now? When you cross multiply, R equals to A over root 3. This is Y. Now your unknown factor you found. What is it? A over root 3. Now you can substitute this into the equation Y. You can substitute that into the equation Y. Okay. Copy these all things so far. Copy these all things so far. I can erase this one now. Copy these all things so far. Quickly. Hello, students. Quickly. Hello. Done? Tejaswin done. Others? Done. Dursana done. Others? Hello? Done. Vidya done. Okay. So my next step is, I am going to put this R value to here. Now y into x. Okay, y into x. I can write it like R equals to, R is a over root 3, a over root 3 to the power 2 over 2h, okay, plus h over 2. Right. When you square it, it becomes R equals to a square over this root 3 becomes 3 times 2h plus h over 2. Now I can just finalize it in a box. What happened? So the answer will be R equals to a square over 6h plus h over 2. I'm pretty sure everybody would understand this. If somebody couldn't, try by watching the video. If still not getting the way, don't worry. Don't even try to remember this equation. Equation will also provided in the question paper. Only thing you need to know is you have to identify what is A, what is H. That's it. Equation will also be printed in the paper. Only thing you need to know is you have to identify what is A, what is H. That is the only competence level expected in A level. I guarantee you. But for school term test papers, really beware of this equation and copy. Because school term test papers, I have no guarantee. Because there are different stupid school teachers will add unwanted things in the exam paper. But in the government A level, never add. I guarantee. But term test, better to practice. Okay, Lamai, I think you had enough time. Okay. Okay, Lamai, quickly. All right. How to find what this length? What is the length? A. How to find A? This will definitely ask. How to find A? So I have seen this method is also given marks. You can hold a vernier caliper to the tips like this way, and it is a really tedious method. I don't know why marks are granted for that. You just keep vernier caliper like this and get the bus reading. You keep the vernier caliper to the other end. You take that reading as A2. You keep vernier caliper to the last end and you take that reading as well as A3. You get average value for A. How? A average is A1 plus A2 plus A3 divide by 3. Okay. This is one of the method of removing errors. You have to take the average. I told you, during the lesson, I will take you the rest of the half of what? Error calculation. One of the method of removal of error is what? Taking the average. When you are taking the average, the errors will get minimized. To make it sure more reliable result, you have to go for the average method. That is also a random error removing method. Okay, you don't know where the error occur, but finally errors will be diluted. This is one of the random error removal method to get the average. I told you, during the lesson, when right time comes, I will teach. This is one of the way. The other way is different. The other way is different. I will tell you the other way too. Okay. Now you have to keep this actually on an A4 sheet and compress this against. I don't know whether you can see the marks, but I will mark these points with the marker pen. Okay. Now I have completed the points. You can. Okay. So you have to use your ruler. Keep in contact like this. Contact like this and draw one line. And draw another line. Okay. Now you construct your triangle. What you can do is you can keep your ruler over like this. Take the reading 1, take the reading 2, take the reading 3 and apply to this equation and find out the average. Can you understand it? Can you understand it? Can you understand it? Huh? Okay. So do you need a note for that? Do you need a note for that? If you need, I can give you a short note. If not, you can understand. Tell me quickly. We don't have time to waste. Okay. Pasan said no. Vidusana said not needed. Is there anybody who need? No. Lazy. Copy this. That's it. That's it. So as an example, if I get like 3.1 millicentimeter plus like 3.2 centimeter plus 3.3 centimeter, you have to add them together and divide. What is it? It is like 9.6 centimeter and divide by 3. Finally, I get like most reliable answer of 3.2 centimeter. Write this one as an example even. Write this one as an example even. Okay. Okay, students. Hello, students. Yes. Now it is almost the theory finishing time. Theory time is all over. It is like 11 past 5 or something. Sorry, 5 past 11 or something. So the theory time is all over. Now we have to practice some questions that I gave you as the midweek, sorry, on the spot live worksheet. So I did it like a train today. කෝච්චියක් යනවා වගේ කඩාගෙන විදගෙන කරගෙන ගියා. That's the nature of this subject. Sometimes I have to finish whole theory in the same day, because if I split into 2 days, you have no work to do. It is useless. Okay. In some other days, we can manage with questions and stories and everything together. In the next week, we have more time, freedom. Like in the next week, I will be giving you a tune, that is traveling microscope and the other instruments. It is not a printed one. It is a kind of like PDF. I will share you that PDF. It is very simple instruments called triple beam balance, traveling microscope, and the stopwatch, and kind of like electronic balance and stuff. So very simple topics. Actually, I need to explain those things, especially the traveling microscope. I definitely have to give you a note, but other things, very short note and completing. So the instruments will be completely done in the next week. All the questions we can discuss. After that, we are going to start very big unit called mechanics. The most interesting one, most longest one, most essential one, mechanics. So I think I have developed your brain to absorb that one perfectly now, because I didn't give you to follow me. Otherwise, I could have just write like equation and so many questions, and I solved you. I solved you. Look, now I let you to do it, and your brain is now ready to take the biggest lesson. Not in the next week, a week later. Okay. So shall we start some questions today? Hello. Okay. So my dear students, yes, I'm going to that share screen and show you the questions and do it. And let's do it quickly.
Oh, good. Most of these students seem like very lazy. They have like sort of like doing these questions themselves alone and want to sleep early, like something. Once I see like this lesson is over, they have thought like, okay, they can manage it. Okay, no problem. Mm. But still, there are certain students they badly need it. So let's do it. Give me a 1 minute. Spherometer and open it. Okay, so actually the on the spot live worksheet. Uh, Wait, actually we could do that. So I have mentioned it already, like because I wanted to do this with you before starting. But now you know this part, zero error. I was just about to do it before you, before teaching. Mm-hmm. Now you can do entire set of this at home. Let's go for real questions here. Now, will you be able to do the first three parts of the question? First three parts of the question: one, A, B, and C only. I'll leave you like 6 minutes to do that. No, 6 minutes is too much. I'd better give you like 5 minutes. I'm giving you 5 minutes to do that. Open up your on tute and do it. My time allocation is only 5 minutes. Let's start. Okay, start it. Okay, dear students, you can see now how easy this one it is going to be. Let me show you. What is the least count of the spherometer? I told you the least count equation is x over n. X factor is 0.5, or you can write it like half over 50. So that means 2 times 50 is 1 over 100. So that means 0.01 millimeter. That is an obvious answer. Okay. So the diagram shows an instance of testing zero error. Now see the zero error, it is lying beneath. So the reading is like, let me check. Wait. The line is 46, 47. The line is 47. What is the zero error shown in the? It is actually should not be zero error initial reading. I don't know. This is like a turn test paper. That's the problem. In actually kind of like the vernier, sorry, spirometers, we don't call it zero error. It is a reverse reading. So you can see it is going down the one. I told you how to do it. N minus simple n times least count. So the n is 50 minus 47 times least count of 0.01 millimeter. Now have a good look at it. It is 3 times 0.01 millimeter. So the answer is the error is 0.03 millimeter, which is just below. You just mark it like a below. Now the diagram shows a spherometer on a special surface, sorry, spherical surface, and adjusted the calculate the radius of the curvature. what is the reading as shown in the diagram? Now you can clearly see if I enlarge this one and show you. So see, this one is really not gone past 2. It is still 1 point something. Okay. So the reading is the main scale 1 millimeter. Okay. It is 1 millimeter. Oh no, this says like half millimeter things, no? But this scale is given in millimeters. I don't know why this is so lame. It should be half millimeter according to the description. 0.5 millimeter. I can take it like 0.5 millimeter then. The reading. See here it is the error 31. So reading circular scale reading is 31. 31 times 0.01, 0.31 millimeter. Here it shows like millimeter. In the description it gives like 0.5. 0.81 millimeter. Okay. Now it shows find the accurate measurement of the spherical surface. The starting point is below 0 starting. Finishing point is above 0. That means you have to add them together. The real reading is you have to add. This is the starting point. This is the finishing point. Starting to finishing. It is a addition method. So the actual reading is what 0.81 plus 0.03 millimeter. So the actual reading is 0.84 millimeter. Understand? Am I understood? Did you get these answers correctly? So if you might also have taken like millimeters, 1 millimeter, because the scale shows like that. But it is not good. This is how the term test papers, I told you, no? Term test papers are like this. There are many errors. Because for the 50 divisions, you can't have 1 millimeter main scale. It should come up with 0.5 main scale. Okay. Now copy this. Okay. Now the distance between two legs is 3.0 centimeter. Which instrument you use to measure this distance? You can write like vernier caliper, no problem. Vernier caliper. State the method that you follow for accuracy of the measurement of above. What is the method I said? What is the method I said? Huh? What is the method I said? I said to calculating the average to omit possible errors. Calculate what? Calculate average to omit possible random errors. Calculate the radius of curvature using measurement above C2 and D. C2 and D. C2 is here, that is H, and the reading. I told you they never ask you to derive it, but you have to apply the equation. But in term test only, they don't sometimes not given the equation. You may have to remember, but in A level, normally give the equation and ask you to apply real values. It is 3 centimeter means 30 square. That means I write like 30 by 30 twice. 6 times H is like 0.84 plus head of 0.84 divided by 2. So it is nearly 0.42 millimeter. 6, 5, 3, 3, 3. It looks like 84. Here like 10. How many point 3 is? If it is like 6s, it is 14 6s. Right? 3s means, yeah. How many 0.3s are there? 100, and it's going to be 1000. Sorry, 100. 100 of these things, and it's like 14 such things. This part will be 500 over 14 plus 0.42. Five hundred over 14 is 35.7. This is what the reading. This is what the reading. Okay, understand? This is the only competence level they expect. Okay, now I added this one too. What is it? Traveling microscope. So try to find out answers for these things, referring to internet, YouTube, especially YouTube. Don't try these ones. Don't try anything after question number 13, right? So because that is something I think I have to explain. But better to try everything using the help of internet, because this one will definitely give you an advancement and the boost for you to deal with this one in the next week when I explain everything. It is very, very essential to know. Okay. Bye then. God bless you, students. Class is over.